I am going to talk as part of the cloud computing on web data management. The web data management consists of three major things, namely the large data analysis, that is called Hadoop, structured record storage, that is nothing but Peanuts and Sherpa, and the third one is the block storage, namely SAN, SAN, and NAS. So in the case of the large data analysis, Hadoop, scan-oriented workloads will be there, focus on sequential disk I/O will be there, and dollar per CPU circle will be there. In the case of the structured record storage, that is Peanuts and Sherpa, CRUD, CRUD will be there, points, lookups and short scans will be there, index organize table and random IOs will be there, dollar per latency. In the case of the block storage, object retrieval and streaming will be there, scalable file storage will be there, dollar per GB. That will be metered rating. The web has changed today. The web serving applications need today scalability, preferably elastic, flexible schemas, geography, distribution, high availability, reliable storage. Web serving applications can do complicated queries nowadays, strong transactions also. To help you scale your mountains of data, the Peanuts and Sherpa will help you. Yahoo serving storage problem. Small records only, maybe 100 KB or less. Structured records, lots of fields. Extreme data scale, tens of terabyte. Extreme record scale, tens of thousands of records per second. Low latency globally, 20 plus data centers worldwide. High availability, outages cost dollar millions. Variable usage pattern as applications and users change. These are coming under Yahoo serving storage problem. The Peanuts and Sherpa solution. This is the next generation global scale record store. It consists of record orientation, scale output, and pub sub replication to far flung data centers to mask propagation delay, consistency model, cloud deployment model. What is Peanuts and Sherpa? Just you can look at the figure, you can easily follow. What will it become? Again, you can look at this figure, you will follow this. What will it become? Again, look at this. You will find the indexes and views, everything in the figure very easily. What are the design goals now? Scalability. Thousands of machines, easy to add capacity, restrict query language to avoid costly queries. Next, geographic replication. Each replication around the globe, low latency, local access, and the third one is high availability and fault tolerance, automatically recover from failures and serve reads and writes despite failures. The next one is consistency, pre-record guarantees, timeless model, option to relax if needed. The next one is multiple access path, hash table, oriented table, and primary and secondary access. And finally, the hosted service. Applications plug and play, share operational costs. The technology elements, you can look at the figure, you can follow easily. Then we will talk about the data manipulation. Per record operations, get, set, delete possible. Multi-record operations, multi-get scan, get range possible. The tables, hash table, Just look at the figure, you can easily follow that. And the ordered tables, tablets, you can also look at the figure. The flexible schema, this also you can look at the figure, you can easily follow the table. The detailed architecture is given in the figure, you can easily follow. The tablet splitting and balancing is also given in the figure, you can easily follow. Accessing data, it is exhibited in the figure very nicely. Bulk read is also exhibited in the figure. Range queries, how it is possible, you can see in the figure. Updates, you just look at what way the updates are very easily done. And next is replication and consistency. This replication, you can look at the figure, how nicely it is done. The consistency model, the goal is make it easier for applications to reason about updates and cope up with replication. What happens to a record when primary key lies? So this you can look at the model on the figure. Similarly, some examples on social lies, the consistency model, and various types are given in the figures, you can easily follow. Next, let us talk about the consistency techniques. Pre-record mastering, each record is assigned a master region, may differ between records. Updates to the record forwarded to the master region ensures consistent ordering of updates. The next one is tablet level mastering. Each tablet is assigned a master region. Inserts and deletes of records forward to the master region. Master region decides tablet splits. The last one, these details are hidden from the application except for the latency impact. The mastering, you can look at the figure very nicely, you can understand the bulk, insert, update, replace, all you can see in the figure. Very easily you can follow. The type of record stores, this query expressiveness, it is starting from simple to object retrieval and retrieval from single table of objects records and through SQL for Oracle future reach. Say in this case what is happening, the object retrieval is from S3 and the peanut gives the retrieval from single table of objects, Oracle gives a SQL future on, like that. This also you can see. And the types of record store, you can see the figure, data model, elasticity, and all these things are given in the figures. Now let us talk about the data stores comparison. User partitioned SQL stores. Each consists of Microsoft Azure SDS, Amazon SimpleDB. Next, multi-tenant application databases. This is like Salesforce.com, Oracle on demand. Then the third one is mutable object stores, that is Amazon S3. Now, versus peanuts. Now, versus peanuts, more expressive queries, users must control partitioning, limited elasticity, highly optimized for complex workloads, limited flexibility to evolving applications, inherent limitations of underlying data management system, object storage versus record management. You can also see in the figure the application design space. Alternatives or matrix is also given in the figure. Next, let us talk about the Hadoop, the distributed file system. Single namespace for entire cluster, managed by a single name node. Files are single writer and append only. Optimize for streaming reads for large files. Next, the files are broken into large blocks, typically 128 MB, replicated to several data nodes for reliability, access from Java, C or a command line. The Hadoop clusters, I am giving a figure, you can see, and research cluster usage also you can see in the figure. Who is using Hadoop nowadays? Amazon A9, AOL, Facebook, for interactive media, Google, IBM, New York Times, PowerSet, now Microsoft, and Quantcast and Rockspace, Mailtrust and Vio Yahoo. So, I have given you some idea on web data management and Hadoop. Hope you people might have enjoyed. Thank you very much.